Hello students, so here we are with the question second of the exercise 3.4 for the chapter pair of linear equations in two variables. So the question second is form the pair of linear equations in the following problem and find their solutions if they exist by the elimination method. The first problem is if we add 1 to the numerator and subtract 1 from the denominator, a fraction reduces to 1. It becomes half or 1 by 2 we can say if we only add 1 to the denominator. What is a fraction? So first step is to form the pair of linear equations from the data being provided in the problem, and then we need to see whether these equations are solvable. If solvable, then we need to solve by using the elimination method. So let fraction be, say, x divided by y, that is x by y. And in the first statement, it's been given that if we add 1 to the numerator and subtract 1 from the denominator, our fraction reduces to 1. So it will be x plus 1 divided by y minus 1 is equals to 1. Right? Or we can write it as x plus 1 is equals to y minus 1. Or x minus y plus 2 is equals to 2. Let me mark this statement as first. Now coming to the second statement in the problem, it says that it becomes 1 by 2 if we only add 1 to the denominator. So by adding the 1 in the denominator only, it will be x divided by y plus 1 is equals to 1 by 2. Or we can write it as 2x is equals to y plus 1 or 2x minus y minus 1 is equals to 0. So let me mark this equation as second equation. So now it's been given in the question to solve these equations by using the elimination method, and as we know, elimination method says that we need to ensure whether or not the numerical coefficient of the variable is same in both the equations. Let us say we are targeting here over the variables y, and we see whether or not their coefficient is same. If we see the equation first, its coefficient is minus 1, and the second equation says that its coefficient is minus 1, which means it is same in both the equations. So what we have to do next is to subtract any one of the equation from the other one. Let's say we are subtracting second equation from first equation. So writing the first equation, that is x minus y plus 2 is equals to 0, and the second equation which is 2x minus y minus 1 is equals to 0. So in order to subtract the second equation from the first, we need to change the sign. That is, here it will be minus, here it will be plus, and here it will be plus. Right? So now adding them, it will be x minus 2x, it will be equal to minus x. Here it will be plus 3 is equals to 0. So from here, the value of the x comes out to be equal to 3. Now substitute this value of x in any one of the equation, either first or second choice is yours. Let us substitute this value of the x in the second equation. So here it will be 2 into 3 minus y minus 1 is equals to 0. From here, the value of the y comes out to be equal to 5. So here we have obtained the value of the variable x as well as for the variable y. Now substituting these values in the fraction, that is x divided by y, here it will be 3 divided by 5. So the fraction for this problem is 3 by 5, which was asked in the question to find the fraction. So this was about the first problem of the second question of exercise 3.4. Now coming to the second problem. So the second problem is 5 years ago, Nuri was thrice as old as Sonu. 10 years later, Nuri will be twice as old as Sonu. How old are Nuri and Sonu? So in this question, the comparison have been made between the ages, that is present age, past age, as well as with the future age of Sonu as well as of Nuri. So in order to solve this question, let Nouri's present age be X and Sonu's present age be Y. So we have been supposing the value of the Nouri and the Sonu present age, which are variables X and Y. So according to the question, 5 years ago, Nouri was thrice as old as Sonu. Means the comparison have been made between the past age and the present age. That is present from 5 years from the present age. So here we will be subtracting 5 in order to obtain the 5 years ago age of both Nouri and Sonu. So x minus 5 will be the 5 years ago age of Nouri and y minus 5 will be the 5 years ago age of Sonu. And what the relation between the 5 years ago age of Nouri and Sonu is, 5 years ago Nouri was thrice as old as Sonu. Means x minus 5 will be equal to thrice into y minus 5. Solving this equation, it will be x minus 5 is equals to 3y minus 15. So from here, x minus 3y will be plus 10 is equals to 0. Right. Let this be the first equation. And the second equation will be formed from the second statement of the problem. So the second statement says 10 years later, Nouri will be twice as old as Sonu. Means 10 years after from the present age, Nouri will be twice as old as Sonu. So in order to obtain the 10 years later age of Nouri, it will be x plus 10. And Sonu, 10-year later age will be y plus 10. And the relation between these two ages is Nouri will be twice as old as Sonu. Means x plus 10 will be equal to 2 into y plus 10. So from here, x plus 10 will be equal to 2y plus 20. Or we can write it as x minus 2y minus 10 is equal to 0. Let this be the statement second. So now we have to solve these both equations by using the elimination method, and as we know, elimination method says we need to ensure that the numerical coefficient of the variable in both the equation is same. Suppose we have been targeting over the variable x in this case, and as we see in equation first, its coefficient is 1 and in second, its coefficient is 1 as well. So now we will be subtracting the equation first. Subtract, say, equation first from second. So writing the first and second equation here, it will be x minus 2y minus 10 is equals to 0. And then the first equation will be x minus 3y plus 10 is equals to 0. Now changing the sign, here it will be minus plus minus. So here it comes out to be y minus 20 is equals to 0 or y is equals to 20. So now substitute this value of the y in any of the equation, either first or second. Let me substitute this value in first equation. So it will be x minus 3 into 20 plus 10 is equals to 0. X minus 60 plus 10 is equals to 0, or x comes out to be equal to 50. Means Nouri's present age is equals to 50 years and Sonu's present age comes out to be equal to 20 years. Let me write here. So Nouri's present age will be x, which is equal to 50. So its present age is 50 years. And Sonu's present age, which is equal to the variable y, whose value is 20. So its present age, that is Sonu's present age, will be 20 years. So this was about the problem second of question second. So now the third problem of the question second is the sum of the digits of the two-digit number is 9. Also, 9 times this number is twice the number obtained by reversing the order of the digits. Find the number. As we know, the number is being formed by the digits, and each digit in a number represents the face value. I hope you know the difference between the face value and the place value. Let us revise. Say the number has been given 987. Now, if someone asks what is the face value of this 9, the face value is the digit itself, that is, its face value is 9. But what if someone asks what is its place value? That is, what is the place value of 9 in the number 987? Then the place value is 100. And coming to the digit 7, its face value is 7 in the number 987, but its place value is unit place. Similarly, with the digit 8. If someone asks what is the face value of digit 8 in the number 987, then its face value is 8, but its place value is 10. I hope you get the difference between the place value and the face value. The digit itself in the number represents its face value, not its place value, right? So, now coming to the problem, what it's been asked, the sum of the digits of the two numbers is 9. So, let us first assume the two digits of the number. Say, let the two-digit number is equals to xy. That is, in 100 place, the value of the digit is x, and in unit place, the value is y. Got it? So, the number, that is two-digit number being formed is xy. Now, the first statement says the sum of the digits of the two number is 9, which means x plus y is equals to 9. This is the first equation. Now, reading the second statement, what it says, also 9 times this number is twice the number obtained by reversing the order of the digits. Firstly, let us come to this two-digit number. As we have assumed that the two-digit number be xy, but as we don't know the value of the x and y, so in order to use this number in the statement, in order to form the linear equation, we will use its expanded form. So, the expanded form will be 10x plus y. Got it? That is by using the place value of each digit in a number. As the place value of x is 10, so it will be multiplied with x, that is x into 10 plus the unit place digit, that is plus y. Got it? So, now what the statement says, 9 times the number, that is 9 times 10x plus y is twice the number obtained by reversing the order of the digits. So, suppose the digits has been reversed, that is y comes in tens place and x comes in unit place. Then the number will be yx, and in expanded form it will be written as 10y plus x. Means this is the form which has been obtained by reversing the digits of a number. So, in statement it says is twice the number obtained by reversing the order of the digits. Means it is 2 times 10y plus x, right? So, now calculating it, it will be 90x plus 9y is equals to 20y plus 2x, right? Or we can write it as 88x is equals to 11y, which can also be written as 8x minus y is equals to 0. So, this is the second equation formed from the problem given. So, now in order to solve these two equations, we need to use the elimination method as it's been stated in the question. So, what the elimination method says, we have to ensure that the numerical coefficient of the variable is same in both the linear equations. Let us say we are focusing over the value of the coefficient of variable y. Looking at the first equation, here the coefficient is 1 and in second it's minus 1. So means as the coefficient numerical value is same, that is 1, 1. So what we need to do is to add the first linear equation with the second linear equation. So add 1 and 2, right? Adding it, that is x plus y is equals to 9 and 8x minus y is equals to 0. So what we will be obtaining is 9x is equals to 9, or we can write it as x is equals to 1. So this is the value of the variable x, that is digit x in this case. Got it? Now substitute this value of x in any of the equation, either 1 or 2. Let us suppose that I have been substituting this value in first equation. Then it will be y is equals to 9 minus x, or I can write it as 9 minus 1 is equals to 8. So putting this value in the number, so the number formed will be xy, which was xy. So substituting the value of the x and y in this number, it will be 1, 8. That is, it's 18 number. So I have found the number which was being asked in the problem. I hope this question is clear to all of you. Right. Now we will be doing the next problem. Now coming to the fourth problem of the question second, it says Meena went to bank to withdraw rupees 2000. She asked the cashier to give her rupees 50 and rupees 100 notes only. Meena got 25 notes in all. Find how many notes of rupees 50 and rupees 100 she received. So in order to solve this question, let Meena receive X number of notes of rupees 50. Okay. And we also let Meena receive Y number of notes of rupees 100. Got it? So now according to the problem, what it's been given, Meena went to the bank to withdraw rupees 2000. She asked the cashier to give her rupees 50 and 100 notes only, that we have supposed to be the variable x and y respectively. Meena got 25 notes in all. Means the sum of the notes of type x and of type y is equal to 25. So what it means that x plus y comes out to be equal to 25. Let this be the first linear equation. Okay. And also it's been given that she had withdrawn rupees 2000. Means the total amount she received, which was being formed with the x and the y number of notes, is rupees 2000. So means we can write 50x plus 100y is equals to 2000. So this is the second linear equation formed from this problem. So simplifying it, it will be x plus 2y is equals to 40. Let me mark the statement as second statement. So now we have obtained the two linear equations from this problem, and we know the solution to this linear equation will be solved by using the elimination method. So what elimination method says that the coefficient of the variable should be same in both the equations. Now suppose we have been focusing over the variable x, and as we see the equation first and the second, its coefficient is 1 in both the cases. So now we will subtract equation first from second. You can also subtract the second equation from the first, choices being yours. But I am subtracting the first equation from the second. So writing the first equation, that is x plus y is equals to 25. And also the second equation, x plus 2y is equals to 40. Since we have to subtract the first equation from the second equation, we will be altering the signs of the coefficient of equation first. Got it? So here it will be y is equals to 15. Got it? So now substitute this value of y in any of the equation, either 1 or 2. Suppose I have been substituting in equation first. So here x will be equal to 25 minus y. And substituting the value of the y, which is equal to 15, the value of the x comes out to be equal to 10. So means we can conclude over here that the Meena receives 10 notes of rupees 50 and she receives 15 notes of rupees 100. Okay. Now it's been asked, find how many notes of rupees 50 and rupees 100 she received. So she received 10 notes of rupees 50 and also she received 15 notes of rupees 100. Now we can verify it by substituting these values in the second equation. That is, whether or no the total amount being formed by rupees 50 and 100 rupees note is equal to 2000. Now let us substitute it. So here 50x, here x value is 10 plus 100y, and substituting the value of the y 15 and calculating it, it will be 500 plus 1500, which comes out to be equal to rupees 2000. Means this is the correct answer which we have obtained for this problem. So this was about this fourth problem. Now coming to the fifth problem. So the fifth problem is, a leading library has a fixed charge for the first 3 days and an additional charge for each day thereafter. Saritha paid rupees 27 for the book capped for 7 days, while Susie paid rupees 21 for the book she capped for 5 days. Find the fixed charge and the charge for each extra day. So in order to solve this question, we will let fixed charge be rupees x and also we will let charge for each extra day be rupees y per day. Okay. So now if we read again the question, what it says, Sarita paid rupees 27 for a book capped for 7 days, while Susie paid rupees 21 for the book she capped for 5 days. So for Sarita, which she have capped the book for the 7 days, for the first 3 days, there will be the fixed charges. And for the rest 4 days, there will be additional charges, that is rupees y per day. So the equation formed will be x plus 4y is equal to 27. This is the first linear equation, and the second linear equation will be formed as it says the statement, Susie paid rupees 21 for the book she capped for 5 days. So the total number of days she capped the book is 5 days, out of which, that is for the first 3 days, there will be fixed charge which is rupees x. And for the rest 2 days, there will be rupees y per day charge. So the equation formed will be x and rupees y per day charge will be for 2 days. So it will be 2y is equals to 21. So this is the second equation, right? So now as we have obtained the 2 linear equations from this problem, now we will be solving this by using the elimination method. What elimination method says that we need to keep in mind that the coefficient of the variable remains same for each of the linear equations. That is, the numerical coefficient, say for this case be x, be same in equation 1 as well as in equation 2. As we can see, it is 1 in both the cases for the coefficient x. So what we need to do next is to subtract first equation from second, or we can also write it as second equation from first. The choice is up to you. So writing the first equation, that is x plus 4y is equal to 27, and the second equation is x plus 2y is equals to 21. So in order to subtract the second equation from the first equation, we need to alter the sign of the second equation. That is, here it will be minus, minus and minus. Now adding them, we will obtain 2y is equals to 6, or y is equals to 6 by 2, which is equals to 3. So this is the value of the y, that is, charge for each extra day is rupees 3 per day. That is equals to rupees 3 per day. Now, in order to find the value for the variable x, we need to substitute the value of the y in any of the equation, either 1 or 2. The choice is up to you. I am substituting the value of the y in, say, second equation. So here it will be x plus 2 into 3 is equals to 21. X is equals to 21 minus 6, which comes out to be equal to, it's 21, right? Which comes out to be equal to 21 minus 6 is equals to rupees 15. Means the fixed charges which Sarita and Susi has to pay for the first 3 days is rupees 15. So here we will write rupees 15. So it's been asked in the question to find the fixed charges, that is rupees x, which is equal to rupees 15, and the charge for each extra day, which comes out to be equal to rupees 3 per day. We have found both the values. So this was about the fifth problem of the question second of exercise 3.4. I hope this question is clear to all of you.